So let's do a quick reminder of our different ways and forms of graphing here. Right, at this point, we should have seen them all. We've gone through them all, but we just might need some reminders on what each situation looks like and what it tells us. Okay, so remember, we have all those formulas available to us with slope-intercept form, point-slope form, standard form. Okay, but it's sort of our job to know what those letters stand for and what information they give us. So if we look at number 1, right, number 1 looks like y equals mx plus b. Okay, and that is slope-intercept form, which means we can find a slope and a b, which is our y-intercept. Okay, again, knowing that our b is our y-intercept, that tells us exactly where to put our point. So we know a y-intercept goes on the y-axis, and it tells us it needs to go at 4. Okay, then we also should know that slope is always a rise over a run. So right now we have a rise. To give it over a run, right, we're going to turn it into a fraction. So we'll write that as -2 over 1. And that tells us how steep our line needs to be. It tells us how many we need to rise and how many we need to run. So it tells us from this point we need to rise -2. So if we're going to rise -2, we're going to go down 2. And then we're going to run +1. So I'm going down 2, right 1. There is my line. Number 2 is telling us specifically that we have y equals 5. It is telling us our y-intercept equals 5. So on our y-axis, we need a point at 5. Now, there's no x value at all in this problem, which means there's no x-intercept in this problem. So if we want a line that doesn't cross the x-axis, the only way that we can avoid the x-axis is to draw a line parallel to the x-axis, and we get a horizontal line. Number 3, we have y is greater than 2x, so now we have to consider the inequality. Okay, this is very similar to our one right up here. We just don't see our y-intercept, but remember we can fill that in with a +0. Okay, and then when we do that, it's easy to identify our slope, our m, which is 2, and our b, which is 0. So this is telling us our y-intercept. So on our y-axis, we want to go to 0. And we need a slope that rises 2. So we're going to go up 2 and right 1. Now, this inequality says that it's only greater than, not greater than or equal to, which means we are creating sort of the borderline of where we can be, but we can't actually be equal to it. So to show that we can't actually be this line, we can just get as close to it as we want. We are going to use a dashed line. And we want all the values that are greater than it. So any of the points that are larger than this are fair game. They count as solutions. And so we're going to shade all that area above. Number 4, if we look at our formula options, this is in point slope form. It's in our y minus y sub 1 equals m times x minus x sub 1. And in point slope form, we can find a point and we can find a slope. Our slope is always the number sitting in front of the parentheses, so our slope is 1/2. Now, our point is always our x sub 1 comma y sub 1. So we want the number right here, but remember that formula says to take the opposite of x sub 1. So we need the opposite of -5, which is +5. And again, we have the opposite of y sub 1, so the opposite of +4 is -4. Now, we can't do anything with slope yet because we don't know where in the plane we need to be starting. So we're going to have to plot our point first. So we're going to plot the point +5, 5 on the x, -4. And then from this point, now we can consider how steep it needs to be. It needs to be up 1 over 2. And there is our line. Okay, this next one is in standard form. We know it's in standard form because it's in the form ax plus by equals c. And in standard form, the two things that we can find are an x-intercept and a y-intercept. Okay, and we find the x and y-intercept by plugging in 0. An x-intercept always has a y value of 0. So if we plug in 0 for y, that says 3x plus 2 times 0, which is just 0. So all we have left is 3x equals negative 12. And that's something we can solve. So that tells us that our x-intercept is negative 4. Now, for our y-intercept, a y-intercept always has an x value of 0. So now 3 times 0 is 0, which just leaves us with 2y equals negative 12. And so we get a y-intercept of negative 6. So an x-intercept says to go on the x-axis to negative 4. A y-intercept tells us to go on the y-axis to negative 6. And there's our line. Okay, then our last one here, absolute value. Absolute value graphs make a V-shaped graph. So remember, we have some different letters happening here. We have y equals a times x minus h plus k. Okay, so our a value in this one is negative 3. Okay, and then our h comma k gives us our vertex. It gives us that starting point. So again, there's the subtraction here. So we want the opposite of h. So the opposite of 1, which is negative 1. But the k has an addition sign, so we're going to keep the same one there of negative 5. So I'm going to plot the point negative 1, negative 5. Okay, and then this gives me how steep one side of it is. So again, I want a negative 3 over 1. But to get the other side of my V, right, I want that negative 3 over negative 1. So I want that mirror image of it. So now I'm going down 3, left 1. And there is my V.